And welcome Math 7 to Chapter 7, Section 2. We're doing exponent properties with quotients today. Before we do, we're going to do a quick quiz on yesterday's exponent properties involving products. So let's do that first. So go ahead and pause the video and try this problem. Come back and check your answer. And the answer is B. Good job. 13 factors of 3. Let's try this. Again, pause the video and give it a try. This one is the trickiest one. Watch where those parentheses are. Take your time. Okay, and then check it. And the class thinks that the answer is C. So let's check this out. We have, in the first term, we have negative R happening how many times?
3.
Negative R?
3.
3 times. Negative R times negative R times negative R. Will that be positive or negative?
Negative.
3 of them. So it will be negative R, we could say to the third, right? 3 of them. Negative R to the third. The second one, we have negative R squared happening 4 times. Will that be positive or negative?
Positive.
Negative R squared times negative R squared is positive. And then we have 2 more factors. Negative R squared times negative R squared is positive. So this in the middle here ends up being positive. R to the what? 8. Good. 2, 2, 2, and 2. 8. And so now the last one is negative R squared. Is that positive or negative?
Positive.
Negative R squared?
I know.
It is negative. Negative R squared is what it is. So these two, the one on the left and the one on the right, we could write them as negative 1 times R cubed times R to the 8 times negative 1 times R squared. So we have 2 negative factors left here. Your answer was not right, was it, class?
No.
The answer should be A. Because we had a negative factor, a negative term there, and a negative term here. Now, this is the critical spot. Many of you thought that that is a positive. Why is negative R squared not positive? Nico?
Because it's just like, because the squared is in the parentheses.
Good. The negative is not in parentheses. The squared is only affecting what? The squared is only affecting the R. This equals negative 1 times R squared. When you see a negative sitting in front of a term, it's as though it's being multiplied by negative 1. Okay? So this is a negative term. Okay? And that's what that equals. It's really tricky, but the answer is A, and it's all about the details. It's all about the details. It's very difficult giving you partial credit for this because C is absolutely wrong. Okay? Okay, try this. Number 3. We have 4 to the 5th to the 3rd. And your answer is A. Good job. We have 4 to the 5th times 4 to the 5th times 4 to the 5th. 8. And finally, try this. We're evaluating, so you will substitute. Okay, and your letter answer is
D.
Good job, because negative 2 to the 3rd is negative 8 times negative 4 is positive 32. Okay, and then one final question on this warm-up quiz. And so we have an answer that's a letter answer. Once again, the answer is
C. B.
A. Okay, raise your hand. Who says A? We have an A. Who says B? Ooh, a lot of people say B. Who says C? And we have a handful. And who says D? And a few of those. Interesting. We're not all agreeing. So this is why I have it here. Highlight this. This is huge. Huge. When we have D equals negative 2, it is a really common error for somebody to say that this whole thing equals negative 2. But it doesn't. When we plug that in, let me move this down. When we plug the negative 2 in for D, we have negative, we plug in negative 2. Plus, we have C, which is negative 4. Now, what happens to this first term?
There's a positive.
It's adding a positive. It's positive. So if you said B, you got it right. And more people said B than any other letter, so I have hope. There is hope. Okay. So back to the topic for today, the second section of Chapter 7, quotients. We're going to discover, whoops, did I stop that? No, I didn't. We're going to discover a couple of properties, 2 properties involving quotients. So what operation are we talking about when we say quotients? The operation is division. And so you can see it here. We write division using a fraction. The numerator divided by the bottom, right? The denominator. Top dog divided by the bottom. Okay? So what we're going to do is see if we can develop the rule like we did yesterday. So you know about exponents. In the numerator here, we have 10 to the 9th. What does that mean, Bailey? What does 10 to the 9th mean?
10 9 times.
She says 10 9 times, right? So we'll expand it. Okay, 10 times 10, 9 of them. 4, 5, 6, 7, 8, 9. 9 tens. Okay, and then what about the denominator? 10 6 times. 1, 2, 3, 4, 5, 6 times. Okay, and so what do you notice? What can we do here when we have this? Bailey? We can simplify. How would you do that? What is 10 over 10? 1. That we call those multiplicative inverses. Can everyone say that?
Multiplicative inverses.
10 divided by 10 is 1. So we sometimes use the word cancel, right? We have 1 there. 1, 1, 1, 1, 1. So we're going ahead and we're kind of canceling those multiplicative inverses. And we are left with how many tens in the numerator?
3.
3. So we can write that exponentially this way. 10 to the
third.
So now how could we avoid expanding this and go straight from the original expression to the modified one there, the simplified one? Zach? Good. He says, look it, you could just take the exponent in the denominator and subtract it from the top exponent, right? And we would end up with 10 to the third. Very good. So that's what the rule will be for quotients of the same type of power, okay? If you were asked to evaluate this, what is 10 to the third? What is the value of 10 to the third? Michael? How many zeros will it have? It'll have 3. So the value, if you were asked to evaluate it not using exponents, you could write it as 1,000. Okay? Let's try it again. What can you do with this? We've got negative exponents now. One thing we might do is rewrite this so that it doesn't have negative exponents. So that might be a first step for some, right? How could I rewrite this without the negative in the exponents, Nico?
You switch the denominator to the numerator to the.
You could do that, right? And now we have no negatives in our exponents when we move them to the inverse location, right? And now we can apply what we learned over here. In this case, we just subtracted the denominator exponent from the numerator exponent. So we could do that now, and we would have 5 to the 4th. Good. Okay? Now, there is another way to do this, getting from the original expression to the final expression. Does anyone see another simple way to do that? Lexi?
Just subtracting?
Look at that. If you subtract the denominator's exponent, what ultimately do we really do here?
Add the opposite.
Good. Add the opposite. And negative 2 plus 6?
4.
Gives us our answer. So you can just use the rule that we're kind of developing, right? Subtract the exponent from a denominator and you'll have the right exponent. So go ahead and see if you can complete the rule box. So we call this the quotient of powers, which makes total sense because quotient is division. We're dividing powers that have the same base. And so to finish the rule, we have a to the m over a to the n, which equals, Izzy? A to the... Excellent. Good job, Izzy. a to the m minus n. So try it with one more little sample in your rule box. 5 to the 5th over 5 squared equals 5 to the third. Good job, 5 to the 3rd. Okay, now we're going to develop the second and last property for division, quotients. So let's try this. We have a quotient in parentheses raised to a power. So this is called the power of a quotient property. It makes a lot of sense. So we have 5 over 2. 5 over 2 is happening how many times? Twice. So we could expand this. 5 over 2 times 5 over 2. That factor is happening twice. So Sophia, can you write that exponentially? How many 5s in the numerator? So we could say 5 squared, right? And how many 2s are in the denominator? 2. So how could we go straight from the original expression to what we just found? When you have an exponent, what is it affecting in the quotient? Very good. She's saying the numerator and the denominator. They both get the exponent. It feels like you're distributing, remember? Like yesterday? It feels like a distributive property. It's not called that. It is called the, well, we'll see in a second. Okay, could you evaluate this fraction? What is 5 squared?
25.
25. What is 2 squared? 4. So we could even change that to a mixed number if we were asked to find the value. Okay? Next one. Okay, z over 2 to the 6th. Okay, I don't know when this paused, but here we are at z over 2, and that whole fraction is being raised to the 6th. So, having learned what we just did at number 3, maybe some of you are able to skip over the expanding. Who's able to skip over the expanding? Okay, rather than writing this out 6 times, right? How could we write this expression? Sophia? Thumbs up if you agree. Awesome, that's right. Good. And if we were going to evaluate that, we don't know what z is. So that remains z to the 6th. But if you wanted, you could tell me what 2 to the 6th is, right? 2 times 2 is 4, and then I've got 4 3 times, don't I? I've got 3 4s, and 4 cubed is
64.
64. So we could find the value. Okay, here's another tricky one. It's got a negative exponent. Okay, so Tatum, what are you doing with this? Okay, tell us how it looks. What's your answer then? Over, it's actually an a to the 3rd. 10 to the 3rd over a to the 3rd. Thumbs up if you have that. Awesome. So when did you flip it? Did you flip it first? You did? Right away. She just went straight to this. That's awesome. If you didn't do it that fast, how could a person write it before they do this? How could you write it? Lindsay?
A to the negative 3rd over 10 to the negative 3rd.
Good. And then move each term to its inverse location. If it has a negative exponent, it needs to be moved to the inverse location. Good job. So this is called the power of a quotient. Power of a quotient property. And see if you can finish the rule. And to finish this rule, Tessa?
A m over b m.
And we'll have to say to the m. If you just say am, it's like multiplication. So good. A to the m over b to the mth power. And so go ahead and try it. Evaluate this expression that you see. Find the value. And Riley, what do you have?
Well, I could have gone one, but I got c to the 3rd.
Over, good job. C to the 3rd over 4 to the 3rd. And if you wanted to, you could find the value of 4 cubed, which is?
64.
48.
Good job, 64. 4 times 4 is 16 times 4. Okay, and this division or quotient of powers property can be used when we are dividing scientific notation, like we noticed yesterday with the product of powers. So pause and come back and check out the answer. and divide each in part that is alike, and there you go, right? And here you go. Have fun and enjoy.